Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Lunch with Tech Leaders. My name is Adam Oberhausen. I'm the Vice President of Customer Solutions with Right Brain Networks, and I'm your host for today. Joining me today, as always, is my co-host and software and data consultant, Tom Kowalski. Say hi, Tom.
Hello. Howdy.
And our guest co-host today is software development expert and our resident AI subject matter expert, Sir Lance Carlson.
Hello, world.
In this episode, we're going to be discussing something known as observation-driven design. It seems like it's a newer design paradigm and something that Tom's really passionate about. So, yeah, we're going to be basically peppering Tom with a bunch of questions and helping us understand what observation-driven design is. Full disclosure, I had no idea that this was a thing until a couple days ago when I started researching for the show. So,
yeah.
well, it's about the history of this and where you want to begin.
So the history is that you're not going to find anything online that's really public. It's just the name that I put together for everything that I've learned throughout the years as a software architect, taking the good from each of the other design patterns and kind of putting it together. And from the frameworks that we've built, we've worked together. We've built a few frameworks to help us develop software faster, more efficiently, make it easier to maintain. Just the lessons learned along the way. One of them we called observation framework. So that's kind of where it got the name from, because it kind of centers around the idea of treating data as an observation. And yeah, we'll get into it a little bit further. Let me define the problem space. So as a developer, and you're developing a new product, right, or a new solution for something that you have, and you start off, and the requirements always change. So you pick some framework where the requirements work in the beginning, but then now you have to be GDPR compliant. Right, you have to make a bunch of refactoring of how data, needs to be removed, but you still need to maintain records of things that happen. But removing PII, let's say you get a new client integration requires a new API, and maybe the framework that you chose from the beginning just didn't, was REST and support the new API. The new client needs a GraphQL API, and if you have that tightly coupled with the framework and it's tightly coupled to REST, it would require a huge refactoring. You want to leverage machine learning AI, but the data that you have, all this time you weren't collecting it properly to use for AI. So the motivations behind this is allowing you to rapidly prototype, and then at the end of it, having a production-ready system. So that's kind of like the framework that we worked on, and the observation-driven design kind of comes from is kind of the best practices, right? The concepts of that. So any questions so far?
Just to clarify, so when I did some research for the show, I was probably looking at observability-driven design. Which is Have you heard of that approach?
Yeah, that is different.
More focused on like the telemetry and like the basically using the telemetry from production as a key part of your feedback loop when developing systems.
Yes, and that's another part of it too, right? Let's say you change your observability system. You may have to go through and refactor all your code. To put a line in here or a line in there to now start tracking different metrics.
I actually asked my social network on Threads about this, and they said it sounded a lot like design for maintainability, DFM, as far as how I was understanding it, just like Adam was understanding it more about the observability side. But I am more curious now about the development side of this, which I'm not privy to.
Yeah.
The best practice.
Yeah. So I wanted to build up the problem space, get you excited. What is the solution? And the solution to this is standardizing the data and the flow of that data through the system. So there's a lot of other solutions out there, like low code services, right? They handle a lot of this for you. You can rapidly prototype and, you get a production ready system, but as you need to make changes, maybe, it's not supported, there's lock-in. Other frameworks is the same thing we talked about. So yeah, the solution is standardizing that flow of data and the format of it, and keeping things loosely coupled, right, and highly aligned is kind of like the basis, the bedrock of it. So that brings us to the data. How are you guys familiar with cloud events? The format of that. So basically what they tried to do is they took, a lot of cloud providers had serverless offerings and they all have different events. And what they tried to do is kind of standardize that and put a wrap around it. And it was great. The issue with it and the issue with events in general. So the observation-driven design, it kind of follows very closely to event-driven design or event-driven architecture, except it's a little more prescriptive of what an event is. And the very basis of it is, or not really what an event is, but what data is. And the very basis of that is all data is a record of an observation that one entity made of another entity or itself at a given point in time. And once you have that framework, that mental model, you can standardize like a wrapper envelope around all the data in your system. That makes it a lot easier. Any questions on that?
What can you catalog what the different types of entities are that establishes this relationship? Is it a service? Is it, you know what I mean? Like
anything, like all data, right? So the problem with events is that, what is an event? It's different for each observer and what they see. And, an event can come through and let's say there's a timestamp on it. And this is the kind of issue with cloud events. What does that timestamp mean, right? Is that when it happened? Is that when it was observed by one system or another? Is that just when it was recorded, right? When that system saw it? And when you look at all data as just an observation, a record of observation, that timestamp represents when that entity that recorded it, observed it, and recorded it, made that observation of another system or entity. And you can use that model for all data. And this allows you to format it. So you can have a timestamp, different properties, right? Timestamp, trace ID, standardizing how you do the entity IDs or naming of them, the schema version for that entity. As it changes, you can, automatically apply, as you have data migrations, right? As new things are added, changed, being able to maintain that schema version of that entity allows you to do things automatically, right? Whereas if you didn't have that standardization, the different tools, libraries, packages that you're making aren't interchangeable. So if you can, standardize that, you can leverage the same tools, frameworks, packages across all of that.
Is it sort of a framework for just microservices
No.
and
So,
event-driven systems like Kafka?
well, the idea is that it is, event driven, right? But it's so not talking about the framework, kind of. I'm pulling back, right, and just kind of the concepts of it, and not. I don't want to get too much into a specification or, what we kind of did for some of the frameworks that we developed. But yeah, you can think of the design patterns to kind of work for any information system, right? It's not like a panacea. It's going to work for all programming development. But it is, very closely related to event-driven architecture, but just a little bit more prescriptive, right? This is the format of those events, and this is the, flow, standardizing that flow of them through the system.
Are there times when you want to be able to revert? Is it kind of like, it's not part of the framework, or is it sometimes you can create an event trace where you can then start reversing that transaction? Or is it more just like most of the time you're just dealing with events that you see and you don't really operate them on? You never go backwards. You never undo it.
Well, so that's the beauty of it. Once you standardize this and you can put a trace ID on that, you can trace the events, new events events, the observations as they flow through the system. Let's, you make a new observation, that trace ID can, go along with all of that. So you can see what happens all the way throughout the system. You can replay all of those, just like any, event-driven system where, you have that event store. So that's the same idea with the, observation-driven design. You storing all of those observations so you can replay, go back if there's an issue. You have that. So one last piece on the data side of it before I get into the flow is when you think about all of the data as an observation, it also lets you think of all of the data is in the past, right? There's an issue when people say data like this is the current state or the source of truth. But you really never know, right? If you see it in that database, it could change, in a microsecond, and now it's already different from what you saw, right? So every piece of data is an observation that you made, and it has a staleness to it. And once you think of that, it really helps think about data in general. This, from distributed systems to machine learning, all of that data is a record of what was saw in the past. And you should always kind of set the threshold of staleness for that data. Don't think of any data as this is real time. It all is in the past. And you should set that, kind of time to live or staleness for it. Do you need it to be, within a second? Then, maybe you should re-observe that if you don't have the latest. Or, when you think about it this way, it also helps between like client-server interactions. If you want to do things in real time and you're syncing, all of that data is in the past. Any questions on that? Yeah.
So when you say that we in this framework, Tom, you're actually building this framework?
A lot of this goes off of like how we've previously worked together. So we called it the observation framework, or O18K. That's where a lot of this derived from the naming, right? Where we took a lot of the concepts of the loose coupling, high alignment, and kind of put it together in a framework. But yeah, I don't want to get too much into that. But yeah, staying at the higher level, the concepts, the data and the flow through the systems, where this could apply to any system, not necessarily, adapting the observation framework, or even the specification. So yeah, standardizing the flow of it. So again, this wasn't, directly from working on the framework. This is from years of doing lots of projects. The flow kind of breaks down to, you want to, even within a system itself, you want to have pieces in there loosely coupled, highly aligned, or high cohesion, some people say. And what I found, the best way to break those apart within a system are something is observed, something's decided, and something's acted upon. So you have the observers, deciders, and actors. And all of your code could be broken up into those. So with the observe piece of it is kind of like your endpoint, REST API, GraphQL. It takes in whatever is signal request coming in, standardizes it. So whether it's GraphQL, REST, it doesn't matter. It comes together and you standardize that record of observation that was made of an external entity. Then, so this would allow you to have multiple observers for the same observation that is made, right, of an external entity. So you can easily plug in a now GraphQL API because you don't have to worry about changing the format of what it looks like flowing through the system. Whereas a lot of other frameworks, or just when you develop something in general, you get that tight coupling of, this is what it looked like as a, REST protocol format. And it kind of stays that way throughout your system. Where this, what I'm talking about is you should standardize what that looks like before it flows into the rest of the system, to the deciders and actors pieces of your code. Questions on that?
About how that kind of manifests itself in reality.
Yeah. And so then that brings us to deciders, right? And that is where all of your business logic is. You want to have, what we talked about before is, the functional programming. That's why I brought this up. Once you standardize those objects and the flow of them, you can make your business logic, pure functions, purely functional. So that's what you'd want to do in these deciders. It takes previous observations that it observed, the current observation coming in, and using its business logic, it makes a decision. And that decision is passed on to the system to other deciders or actors. And you can standardize. So if you get into like the framework side of it, or, developing your own specification, you can standardize. This is the flow even through that decider. You pull in the previous observations that you need and any other context that you need. And you can, log here, do this. If it's private information, because you're standardizing the data, what's private, what isn't. You set that on that envelope for that data flowing through there. So it's just these different components, observer, decider, actor, know not to store that, right, in your logs. Or if you want to plug and play, hey, I want a different logger, that flow of when things are logged, how they're logged is established. So, you can make those different interchangeable plug-in pieces much, much easier to work across that. So the idea is that it's only, if you really standardize that flow, it's only one decision that can be made by those deciders. And if multiple things need to happen, other deciders care about that decision that happened, that observation of a decision, which, represents an internal model, right? We talk about external entities. You're making observations on those. now this data is an observation of an internal model that made. So when I just say deciders are observing a change to its internal model. And that's what you're storing. There is the concept of it, there is no model that is stored, right? You can store the last observed state of it. And, this is what will help you, right? In leveraging this data for machine learning, for schema changes, data migrations down the road, having that format of it. So what that
things are missing context at that moment of time. How do you grab more context to make that business decision?
It becomes so with that decision, or there's another decision?
Either.
Okay. So within that decider, it pulls in that context, and the context are previous observations. So it's pulling in previous observations / context, what it needs, and the current observation coming in makes that decision, right, in a pure function.
So that's called from a database or a vet log. Like, what is I don't want to get too low level, but I'm just curious how it's pulling it.
It can come from anything, but the idea, it can get put anywhere, but the idea is that it's owned by that decider. I kind of skipped over this, but the general idea of this overall is you want to have as much as you can done declaratively on the top. And so this is the schema of my objects, the entity, internal and external. This is the logic that cares about them. And this is the flow through that system. And you can do all of that declaratively on the top. And then you can implement, what you need imperatively, such as where is it stored in the database. So, at the top, you're saying I care about this observation and these previous observations and, / context, right? You can set all that declaratively. Under the hood, you can implement whatever you want to actually store that, retrieve that data. So does that make sense? You want to write as much as you can on the top declaratively, and then separate that from what is actually implemented. So those things that are implemented, right, if it's a package, plugin, module, can be leveraged throughout the system and other systems, right? If you make it a package. So you can make a repository layer, right, of where you store that. And this is borrowed from other concepts as well, right? Making that repository layer in your code so that you can change the actual data store, what's leveraging it in the future. So, and that's kind of that concept. You want to write it where, hey, send it to the repository to save it. A new observation is made. And this is where I retrieve it. But under the hood, that can be implemented by, whatever data store.
I'm trying to think about, I'm trying to align it with concepts I already use. Is there a controller level, where you're taking in, how does that manifest itself? I guess, and usually I guess I'm just trying to think about this more low level, just to understand how it can be implemented high level. Does this manifest itself in lots of microservices with lots of event systems, and then you're communicating, you have your repository layer that's defining all this, and then that's how you're fetching stuff.
So the idea is the implementation of it under the hood can be done different ways, right? So when we did it as a framework, once you write it declaratively on the top, like this schema flow of it, how it gets implemented, you don't care. So we made it implemented when we did the framework. It could run all on one Lambda function. It could run in a Docker container. It could run, each decider, actor, observer can run in its own Lambda function. But what if you write all declaratives on the top, you don't really care about what's underneath it, right? We also did for the repository layer of how it grabs it. We did some Dynamo. Actually, it's mostly Dynamo, but you could implement whatever layer you want to use.
Got it.
That. Yeah.
Cool.
So that brings us to the actors, and that's where you interface with external systems. So whether that's sending out webhooks or sending the response back from a request, or if it's GraphQL sending out if people are or if other systems are subscribed, sending that out. If it's GraphQL, and where the difference is that there's no decisions being made. So what happens off the actor actions is that you shouldn't do anything off of that, right? That's kind of like that barrier, that boundary for it. Are there any questions on that?
Just really is just sending the request to its final destination, or it's not really doing any thinking or deciding. It just takes whatever was decided in the decision and sends the data along to where it needs to go.
Like an adapter.
Yeah, so it can have some persistent storage, but that's only for maybe like caching, or something needs to be formatted differently for downstream. But it really shouldn't have any persistent storage, right? It doesn't care about what has happened previously, unless it's needed for that specific downstream that it's communicating with. The only one
handles like retries and errors and stuff like that with communicating its stuff, other stuff.
Yeah. The only component, right, is that has persistent storage of observations would be the deciders. That's it. I just do that, and then everything's loosely coupled, highly aligned, and you're off to the races. So I mean that's at a high level, and I kind of jumped around, right? Because what's from the framework, versus specification. That's kind of working backwards. Like as we worked on these things, we kind of what's the actual specification? So it doesn't matter what language you're in, what we implemented in specific language, what's kind of like that standard. And then, as we did that, there was just kind of like a higher level concept. And that's kind of what I'm presenting here, is like what we were calling observation driven design. And there's a lot more to it, right, under the hood and going in it. But at a high level, it's formatting that data, right, putting that envelope around it, so that you can standardize the different tools and how it interacts with that data, and then also how it flows through the systems.
I'm sorry if I'm confused here, but what's dealing with the incoming data format? Is that also an actor, or is that
that's the observer?
The observer is the one. Is that the one converting, let's say, incoming input and then changing it to the format that you want?
Yes.
Okay.
Yes. So as it changes, you need to have another API, a different way of it coming through, a new authentication layer. That is all handled on that observer. So the downstream doesn't care about it when it gets, changes. And this is all done, some people want to say like, oh, well, what if, the request response, so if you're running on a Lambda, right, the request and response has to be done in that same running function, which you can do. You can implement that, under the hood. But the idea is you write it declaratively, loosely coupled. So one day, if Lambda does allow you to break up that request and response, and kind of how they do for WebSockets. You kind of get that ID, and another Lambda function can respond back on that D for WebSockets. If they implement that for the REST API, all you have to do is make a little line change, and now you can break that up. As long as you define it declaratively on the top, right? That implementation layer of either plugins or modules, packages, whatever you're doing, can implement that differently. So,
can you share any real world examples of you implementing this?
Yeah, all the projects that I've worked on that were bigger in the past, implementing this for the last few years in some capacity. I mean, I can go over the project names, but you know what I've worked on in the past together. But yeah, these concepts are what we baked in working with the engineers, the different teams in the past.
Yeah, can you give me a real world example of
what did the system do?
Step by step? Yeah.
Yeah. Let's walk through it. What's an example? Let's say just I don't know, cash register transaction. It's so a user pays for something, right? The observer sees that request that comes into the client. It translates it from a HTTP request to a new transaction observation. It observed the user or whatever you care about in the system. It observed a person, or it observed another system that actually maybe did the transaction, third party system that did the transaction, converts that to a model, or it converts it to an observation schema that it cares about, that kind of represents that external entity of a new transaction. And then that flows the decider that cares about it. Hey, a new one came in. You write declaratively on the top, if a new transaction comes in, this decider cares about it. It decides that it is valid. It's, maybe checks against previous transactions, checks to see if there's enough inventory, right? You're selling something that pulls previous observations. It decides, yes, this is good to go. I observe a new internal model, right? That decider observes and sends out. And maybe downstream things care about it. If the transaction is good, then, send a receipt to that user, right? That if there's logic involved, it could be another decider that handles that. Do they want to get receipts? Do they have an email on file? Another decider decides that, makes the decision, they need to have a receipt sent to them and then that in turn, an actor would look at and see and say, okay, email them the receipt, or send it in a push notification, or, call this other downstream service that stores receipts for them. So it's kind of like the event-driven model, right? Of, flowing through that system. It's just a bit more prescriptive of, not just events just flowing through the system, standardizing those groups of observer, deciders, and actors, keeping that business logic only inside the decider, so that you can change how things are sent, how things come in, very easily without disrupting the downstream. It's taking that event-driven model for external systems working with each other and putting it internally. So
can deciders be asynchronous?
That's the thing. Declaratively on the top, everything's asynchronous. Everything, is assumed it happens instantly and asynchronous, or it could take a long time. You don't know. That also allows you to automatically build in support for race conditions, right? Declaratively, it's all asynchronous. So you have to implement handling those race conditions in the implementation. You don't necessarily have to do it yourself. If there's, you can build those modules, those packages that handle that for you. And then on the top, any systems that you do, you can reuse those because it's assumed that it's asynchronous. So if it isn't asynchronous or it needs to flow in a certain standard, you can, use that implementation under the hood to handle that. Does that make sense? Kind of answer your question? So yes, it could be synchronous, but you want to develop it. You want to write it on the top layer declaratively. You assume it's always asynchronous, and that kind of forces you to support it being asynchronous.
For this paradigm for you, are you trying to, formalize this paradigm and publish it, or?
Yeah, I've been, working on this, putting it together, kind of talked about it with a few people. This is the first time I've formally made it like public, talk to a few people, and then just the teams that I've worked with. So yeah, I do want to, keep working on this and talking about it. Does this make sense to every engineer that I talk about? Does this fit in what you work on? Right? I want to expose myself. All the projects that I've worked on, I think about this framework. How does it fit in there? Does it work? And, whereas, or paradigm, not necessarily the framework, does it fit? And, what I've come up with, everything that I've done so far, it fits and it works with, right? I don't want to say it's like panacea for all of it, but it does fit. So yeah, if you are interested, I'd love to work with whoever and kind of formalizing it and making it, cleaner. Cause yeah, it's just a lot of notes and yeah, I'm trying to formalize it. So yeah, if anybody, if it intrigues you and yeah, you want to know more, reach out to me.
Yeah, I think there's maybe an opportunity for an open source repo where you kind of, one day get it all kind of formalized and defined, and it's like out there for the public to consume, right? And people to contribute on. So, and yeah, if you want to talk more about it in a future episode, if you have more of it fleshed out or want to dive into other areas of it, we'd be happy to have the conversation. So,
yeah, I just want to recap real quick, right? The idea is to treat all of your data as an observed record in the past, right? You should set all of your data. You should think, what is the staleness? What do I care about? Like how old it is. The other thing is you should set that standard, right, for envelope to wrap all of the data throughout the system. That the timestamp when it was observed by the system, that a trace ID. And again, like I've worked on, what that trace ID looks like. So yeah, if you want, we talk further from the specification and what we use implementing frameworks in the past. But you at least need to have a trace ID that flows through there. The idea of making it loosely coupled, highly aligned, right? That declarative, write as declarative as much as you can, and your business logic in pure functions. So the schema, the flow of the data, who cares about it? That business logic, that you should try to write that, as declarative as possible. Yeah, and then breaking up your code between observer, right, what comes in, transforming that, the deciders, the business logic, keeping those together, and then the actor, what's working, downstream, interacting with other external systems.
Good recap. All right.
Thanks.
Well, we want to take this opportunity to thank all of our listeners for tuning in today. We hope you found the conversation informative and valuable. Love to have you again. Join us for our next episode where we're going to be going into task estimation and measuring engineering productivity. So be sure to tune in next week when we dive into that topic. Excited to talk about it, and hope everyone has a great rest of their week. Take care.